The basic description of a photographic lens is focal length, because this determines how much of the world in front of your camera you will be able to fit on your image sensor. In other words, how much will you be able to see through the eyes of your camera? In this lesson, you're going to learn what focal length is and how focal length and field of view are related. The first thing to sort out is what focal length actually is. Despite what you may have previously thought, focal length is not a description of how long or short a lens is physically. Focal length is the distance in millimeters from the optical center of the lens to your camera's image sensor when the lens is focused at infinity. The optical center is the point where all light rays intersect inside the lens. Unless you're going to pursue a career in optics, we really don't have to go too much further than this because it's more important to understand how focal length relates to what you see. The focal length of a lens determines its angle of view, or field of view, and thus how much the subject will be magnified or reduced for a given photographic position. A shorter focal length results in a wider field of view. A longer focal length results in a more narrow field of view. This is one of the most important things to understand about lenses, because the focal length of a lens is telling you how much of the world you will be able to see from your current position. For example, if you're standing here and you're trying to shoot a building with a 50mm lens, you would get this much of it in your frame. In order to get more of the building in your shot, you basically have three choices. You can stand in the same spot and shoot multiple images, and then stitch them together in Photoshop, stand in the same spot and use a shorter focal length, like 18mm, or use the same 50mm lens and move way back to get the building in your shot. What this example shows is that one focal length is not good for all situations. What if we couldn't move back? Then we would have to rely on the stitched method, but we do have options. In this example, we were using a fixed focal length lens, which is called a prime lens. Most photographers will start out with a zoom lens, which is essentially a variable focal length lens. With almost any interchangeable lens camera system, you can get a fantastic range of focal lengths in lenses that cover super wide to the very, very tight. Later in this course, we're going to explore how focal length affects composition and how it affects people's faces. For now, we need to talk about sensor size. Somewhere along the line, you may have heard the term crop sensor or digital photo lens. First, let's talk about crop sensor. Digital photo cameras have sensors that record the images projected by the lens, and sensors are not all the same size. The quote-unquote standard is full frame, which is the 35mm film equivalent. If your camera has a sensor that's smaller than full frame, which most of the cameras in the world are, then it's a crop sensor. There are three major categories that camera sensors fall into: full frame, APS-C, and micro four thirds. There are more sizes than this, but these are the most popular. Camera makers have different names for these sizes. Nikon calls the full frame format FX, while Sony and Canon call this full frame. Sony and Canon use APS-C to describe the sensors that use the APS-C format, while Nikon calls this format DX. Finally, micro four thirds is pretty much called micro four thirds by everyone. The word crop is a reference to what happens when you stick a lens on these cameras. If we put a 50mm lens on a full frame camera, we would get an image that looks something like this. If we put that same 50mm lens on a camera with a smaller sensor, like an APS-C size, we would get a different image that looks something like this. If we put that lens on a micro four thirds camera, it's going to look like this. The lens is the same on all cameras, but the images look different. What happens is that a lens acts like a projector. Light from the world in front of the lens is projected and brought into focus on the image sensor. On a full frame camera, it looks like this, but an APS-C sensor is smaller, so it looks like this. Essentially, we are seeing less of the projected image. A micro four thirds camera is even smaller than APS-C, so it sees even less of the projected image. The effect is that the smaller sensors are cropping compared to the full frame sensor. This doesn't mean that the photos will be smaller, because these smaller sensors may have the same or more pixels. Because they are only seeing the center portion of the projected image, they are seeing less of the world. This means that in order to get a shot that is comparable on a camera with a smaller sensor, we have to use a shorter focal length lens, or move back farther to get the same composition. Now, at some point, someone may have told you that a 50mm lens on your APS-C Canon camera is really an 80mm lens. This is sometimes referred to as equivalent focal length, but it should be called equivalent field of view. The reason is a 50mm lens did not change its focal length once you mounted it on a different camera. What changes is the crop and the equivalent field of view. So, a 50mm lens on a Canon APS-C sized sensor is similar to an 80mm lens's field of view on a full frame camera. This is also referred to as a field of view crop factor. APS-C has a crop factor of 1.6x for Canon cameras and 1.5x for Nikon cameras. Micro Four Thirds has a 2x crop. A 50mm lens on a Micro Four Thirds camera would have a similar field of view to a 100mm lens on a full frame camera. Unfortunately, if you have not spent time shooting on a full frame or film camera, this is all rather meaningless. The way I like to think about it is like this. A crop sensor camera will be tighter, and getting ultra wide angles will have more distortion. Once you start shooting with your camera for a while, you will start to understand how to interpret this equivalent field of view much better. For now, just remember that a lower focal length means wider, and a higher focal length means tighter or more narrow. When you're looking at lenses, you might see a term like digital lens or designed for digital cameras. Canon calls this EFS, and Nikon calls this DX, and other lens makers have different names for this as well. These lenses are designed for smaller APS-C cameras. This enables them to be made smaller and lighter, containing less glass, and be less expensive. Some of these lenses, like this Canon EFS lens, cannot be mounted on a full-frame camera because of this rear lens element that protrudes out of the back of the lens. Even though the Canon mounts are the same, this rear lens element would hit the mirror on a full-frame camera, and that would not be good. This is not true of all lenses. For example, this lens right here, made by Tokina, was designed for digital cameras, but it does not have a rear lens protrusion. So this will actually fit on a full frame camera. However, because these quote-unquote digital lenses are designed to cover a smaller image sensor, sometimes they won't fill a full frame sensor, which means that even though you can fit this on a full frame camera, specifically a Canon full frame camera, the projected image from this lens would not cover the sensor, which means that you'd get black along the edges. It would project kind of a circle right in the center of it. Now, in some zoom lenses, some parts of the focal range will actually cover a full frame sensor. For example, on this lens right here, I believe once you get past around 14mm, it will cover a full frame image sensor. But at its very widest, which is 11mm, this lens won't. And you basically have a circle right in the center of your full frame imager. We will explore focal length and how it affects images and composition later in this course. For now, you're ready to move on to the next section, where you're going to learn about aperture.